Hello everyone, and welcome to SydneyAlt.net May. So if you're here, chuck something in the comments so we know you're there, and we'll just wait a sec till the number of people comes through so we can see that we have someone listening to us. So sorry, a little bit late to start today, but we'll get going soon.
That was my fault. Apologies, everyone.
All good. We actually usually start like a minute or two after 7 anyway, so people got used to it. All right, looks like we've got people watching, which is good. Anyone want to write back? Here we go. We've already got a question.
There we are.
How significant, this is a question for you, Simon, before you even started the talk. How significant are these Copilot and PCs with the ARM chips?
Well, I think actually the secret, that's a good question. I don't work for Microsoft, so I don't know from a business strategy standpoint how insignificant they are, but I think they're a recognition that being able to do neural processing on a edge device is super important. And I think ARM is one component because obviously it gives you that power to processing ratio, but actually the secret for those Copilot plus PCs is the neural processing unit, or NPU, the embedded in the device, which is where the kind of the Copilot Gen AI stuff is going to run. So I must admit I'm not deeply across what was announced there. I'm a cloud guy, software guy, and not a hardware guy. But from what I understand, the NPUs are kind of the thing to look at with some of those Copilot plus PC announcements. So I don't know how. Let's have a look. See. So someone said, "Hi all. Person with the correct answer gets a JetBrains license." Wow.
You can't make that call. That's my call to get the JetBrains license.
So it's interesting to note that the best add-on for the JetBrains IDEs these days is the GitHub Copilot chat, which we won't look at tonight, but I've been doing a lot of training with people, and definitely comes up as one of those key things. I'm just going to have a quick look. Anything else? There we are. Good question. Yeah. Hi all.
All right. So maybe we'll get rolling. So in terms of the JetBrains license, which seems to have already come up, stealing my thunder. Yes, we'll ask some questions at the end, a couple of questions, and whoever answers first will get the choice of the JetBrains products, and there's 2 of them to give away. And we have Simon here, as you might have guessed. He's already answered a question even before being introduced. So yeah, Simon's going to tell us about GPT-based cooking assistant using RAG, and he's promised to do it in 30 minutes, which sounds like a pretty serious challenge. So we got a few more hires coming in. Now, for next meetup, maybe we'll talk about it towards the end, but we're wondering whether there's interest in a pub meetup as opposed to a talk for next month. So yeah, if that sounds attractive, then chuck a message in now and we'll talk about it more at the end as well. France, you got more to add at this point?
I just want to say I'm wearing a JetBrains t-shirt. I don't know if you can see it.
You can't see it because of the fake background. Did you notice our twin fake backgrounds, by the way?
There we are.
We decided that we'd just be in the same room almost.
I was about to say, you're kind of concerning that you both seem to be sitting in the same place.
But just somehow on the wrong side of the mirror.
Yeah, we're just in a parallel universe. That's he's on that side, I'm on this side.
All right. Well, maybe we'll hand over to you, Simon, at this point. You ready and set?
Yeah, absolutely. Let's get to it.
All right. So I'll pop up your slides here. There we go. And yeah, as we go through, as usual, chuck some questions in the chat, and yeah, I'll interrupt Simon at an opportune point and pose your question for you. And then, have you got Twitch open as well, Simon?
I don't, unfortunately. No,
yeah,
I've got I've got the chat open in StreamYard, so I can see the comments that are coming in.
Oh, okay. Yes,
there,
that'll be fine.
I may not, if I don't see your comment, apologies. I will definitely get to it, or either James or Francis will point it out to me. So I'm looking.
We'll make sure.
And the comments are down there. So unless you want to see the top of my head all the time, I will continue to look up here.
Yeah, no worries. I'll service them as we go.
The more I talk, the less of the 30 minutes I have to build this assistant with RAG in less than 30 minutes. So let's get into it. And actually, I'm not going to start by building an assistant, because I want to talk a little bit about the whole Gen AI piece, understanding a bit about fundamentals before we even start to talk about what RAG actually is. So you might have seen that acronym floating around a little bit and wondered what it is. And as part of this, I'm just going to go through some of the fundamentals, and then we will actually build our GPT-based assistant in less than 10 minutes, in fact, is going to be my challenge. So we'll see how we go. My name is Simon Waight, as James said. My blog is there on the screen. I'm an Azure MVP focused on the Azure OpenAI service, unsurprisingly, hence why I'm here to talk about something related to that this evening. But I've been bumping around inside the dev community in Sydney now for a number of years. So you may have seen me at alt.net before. As luck would have it, I actually have another meetup that's going on in another room where I am right now, which is why I was a little bit late this evening, so apologies for that. So one of those weird things in life where everything comes together at one point. So let's get into some of the background. As I said, we're going to take a look at how the Azure OpenAI service provides access to the OpenAI models. You might be wondering why there is such a thing called the Azure OpenAI service. I won't spend a huge amount of time on that, but I think it's worth just talking a bit about it. Generative AI foundations, as I said, introducing the concept of RAG. We'll talk a little bit about this new structure called an assistant and how that works. We won't dive into how to implement one specifically, and then that demo, which is where we'll face that challenge of building our agent in the shortest time possible. So you've obviously all seen ChatGPT. You've obviously heard of OpenAI, the company, and you've probably seen Microsoft's investment in that business. And you might be wondering what the relationship is between Azure OpenAI Service and OpenAI itself. And actually, at the core, the service provides access to the same models as you can get if you go directly to OpenAI itself. So whatever models you'll see serviced through OpenAI's RESTful models that you can sign up for and transact with them through are available through the Azure OpenAI service. And typically, there's about a week delay between a new model announcement and it actually standing up inside of Azure. And once a model is deployed by Microsoft and available for you to use in your own APIs, it gets frequent updates at the same sort of cadence that OpenAI releases them internally themselves. The RESTful APIs are compatible. So if you look at a lot of the samples that are out there to build services against Azure OpenAI service, they often include at the very top a little switch that says whether this is running against OpenAI or Azure OpenAI. But apart from the authentication mechanism that sits around the outside of the RESTful API, they are effectively the same APIs for all intents and purposes. What Azure does give you versus OpenAI is it gives you access to kind of the hyperscale compute that sits inside of Azure's range of data centers. So as you may be aware, OpenAI actually does all of their training and provides their direct services off of Azure themselves. But what the Azure OpenAI service does is it provides you access to compute in any Azure region where the Azure OpenAI service is available, and it provides it in a way that probably scales much further than you would get than the service provided directly by Azure by OpenAI itself.
Simon, is
yes.
like the Azure versions, do they run faster than the ones on OpenAI?
So it's interesting. Just one question I had at the meetup here was about that specific question. So some people have looked at OpenAI versus Azure OpenAI and said, well, actually, from what I can see, the OpenAI service responds quicker. So that's true in some circumstances, and there is a reason for that. So there's, without wanting to get into too much detail, out of the box, when you sign up to use the Azure OpenAI service, you get access to almost like a multi-tenant version of the Azure OpenAI service. Now, if you're a customer that's looking to do large-scale generative AI solutions, you would most likely look to step up to a separate offering tier called a PTU, which gives you access to basically a guaranteed throughput for the service and high performance, and takes you out of that multi-tenant environment for Azure OpenAI service endpoints. The other reason that you see the slight difference, and I do talk a bit about this later in the slides, but we'll talk about it now, is one thing that you don't get out of the box with OpenAI is you do have the baseline sort of protective measures and guardrails that OpenAI puts into all their models to stop them doing, really egregious things when people send them really bad requests. Microsoft goes beyond that. So Microsoft has this general concept of responsible AI, and as part of that, and it's now actually a standalone service that overarches all of the AI services inside of Azure, is this thing called content safety. So any request that you send through the Azure OpenAI service to any of the models except for one goes through a content filter. And that's both an inbound content filter that looks at the user prompts, so the content the user is sending to the service. And then there is a return filter as well that looks at the data that is actually being generated and returned by the service itself. So obviously there's an overhead to that process happening. It's not a massive one, but it might be would be where you might see a slight variation in performance between the OpenAI endpoints and the Azure OpenAI endpoints. But having spoken to a bunch of people that have made the transition from OpenAI to Azure OpenAI, the general feeling is that they get a much more stable throughput and performance than they do with OpenAI, which tends to be a bit spikier, where they might have really poor performance for certain periods, whereas Azure OpenAI is more a more balanced throughput and behavior. So hopefully that answers that question. So
we're going to go more actually. Sorry, Simon, on the filters actually. So yes, it is. I've seen a demo where it's configurable, right, on the filters. Yep. So is the strength of the Azure content filters configurable?
It is, and I'll tell you the one, and this might be your giveaway prize, James. I don't know. We'll see how you feel about this. It's up to you.
You can't tell people, although no. It has to be a surprise what the question is.
Okay. So I'll tell you anyway. So the Whisper model, which is the one that allows you to do video and audio transcription, does not include content filtering. So it's the only one of any of the models that's available that doesn't have content filtering. You can, in some circumstances, request Microsoft to disable filtering on any of the other models, but you have to have a very strong use case why you would want to totally turn it off. And I know a few people that have tried and have been denied that request. It is configurable. It's across, there are a series of tiers, and I'll have to look them up, but basically you have things like self-harm, hate speech, and a couple of other areas, and then there are low, medium, and high levels for each of those things. By default, when the service is enabled, it's set to medium across all of those filters. You don't have to do anything. You don't have to seek permission from Microsoft to change those filter levels. You can change them from low to high at your choosing, but you can't disable them out of the box. That's not something that you can do. So it is configurable. And even so they've added additional capabilities with things like jailbreak protection, and you now have the ability to add filter words in as well. I'm less inclined to use the filter words because I know the sorts of trouble they can cause if they're not used correctly, but you can use your own set of filter words. So that might not necessarily just be, say, profanity. That might also be service trademarks that you don't want to appear in any of the responses that the bot or the backend might generate. So that's a good question.
We got one more actually. We got lots of questions, which is good. So Stephen's asking, will it help with filtering out hallucinations?
That's a good question. Well, it won't, because what do you define a hallucination as, right? Like, you need to think, we as humans can look at a response from an AI service and fairly easily determine whether or not it's, it's accurate or not. And it could actually be that what we want the model to do is we actually want it to hallucinate, right? That's the idea of creativity. So we'll talk a little bit about that later on. The idea of temperature and top P. And the more random the responses, the more likely it is to generate garbage or to hallucinate. I'm not a fan of the word hallucination because it's actually just the model making an error and being inaccurate, but we might want it to do that in certain circumstances. So to answer the question, no, the filters are not designed as they stand today to deal with hallucinations. The idea is that by controlling the data that goes in and comes out of the system, that you reduce the chances of it hallucinating. But again, you might actually want something that's creative. That's right, at the end of the day. Hopefully everyone's still there. Just saw everything drop for a second. Yep. Look, let's crack on. If you've got any other questions, chuck them in the chat. So the OpenAI service is just one part of Azure's overall AI play. So outside of the OpenAI service, Microsoft now has this general idea of the Azure AI service. And it's a pretty amazing clearinghouse for any open source or OpenAI model that you might want to go and work with and understand and use in your solutions. So whether it's something like Mistral Large or Llama 2 or any of the other things from, say, Hugging Face, you'll find a lot of those models that are available to you through the Azure AI service that you can then use to build out your solutions. So Azure OpenAI Service is only one subcomponent of that, really. And the beauty of that is that when you start to build against the Azure AI service, it gives you a standard design surface against which you can use all of these back-end models effectively. So I look at the Azure AI service as almost like a semantic kernel or a LangChain for models as a service. It's super powerful, and I think it's a smart move by Microsoft to have done that. And then the final point is there's nothing customized about these OpenAI models apart from those content filters that we talked about. If the model doesn't do something for OpenAI, it doesn't suddenly magically start doing it inside of the service that Microsoft offers. So you've got that comfort of compatibility between the OpenAI implementation and Azure's hosted version of it as well. Cool. Where do we go next? Not enough screens here. So let's just quickly talk about generative AI models. I can see that a few of the folks in tonight's meetup know their stuff. So apologies if you've seen this before, but I think it's really useful to set the baseline. So a generative AI model is still a type of machine learning model. We know a lot about those, and we've been doing them for a while. But unlike a lot of more traditional machine learning models, GPTs are designed to create something new rather than just predict something off of a fixed data set. So a GPT at a very high level is just a probability machine that generates a specific number of text items or tokens that complete something that it's already been provided with, which is a bit different to what we've traditionally seen machine learning do for us in all of the use cases that it's been used with before. One thing that large language models are very good at is natural language processing, which is where you'll see them come to the fore, and why things like chatbots have kind of been the go-to use for GPTs. But obviously you have things like DALL-E and the new GPT-4V, so the multimodal model, which can do text and images. But typically natural language processing is the power for GPTs. Something that often I see people get confused about is this idea of training or fine-tuning a GPT model. Here, I'm saying that they don't learn from inputs and they're static. It's not 100% true across all models. Certainly with the OpenAI GPT models, they are static models. They don't take any of your inputs and learn from them. If you use the free ChatGPT consumer model, you'll see that when you sign up, it warns you that they'll take anything you give it as training input data. When you use the commercial models or you use the Azure OpenAI models, anything you send to the the models on the back end is not kept and used for training or any other purpose by Microsoft or OpenAI. And I think this one's an interesting one to understand, because what it means is that you can theoretically take, say, a single GPT-4 model, deploy it in your enterprise, and then you can use that model for any number of use cases because it's a general model. It's no longer a specific customized model that's just good at, say, object detection or image recognition. It can be used for any number of use cases as long as you provide it with the right setup when you make a call to it from your front-end applications. So the way we look at the power of a GPT model is looking at the number of parameters that a model has. So this is basically, if you want to think of like the human brain is represented by a massive array of neurons, which together builds a neural network. So the idea that these models are trying to represent a type of neural network or a human brain. The more parameters that a model has, the more neurons it has, the more possible pathways through the model there is, and therefore, theoretically, the more power that it has. So when we talk about model size, let's just have a quick look at what that is represented with. So this is a slide from lifearchitects.ai/model, so it's updated fairly regularly by the author of that site. So ChatGPT, which is based on GPT 3.5 Turbo, which is a little bit long in the tooth now. It's been about for a little while. It has 20 billion parameters. And then if we think about something like GPT-4, which was kind of the breakthrough that everyone saw in the last couple of years, it kind of stepped that up from 20 billion parameters to 1.76 trillion parameters. I think that's an estimate. I don't think OpenAI has actually published the number of parameters that they have. And then you see things like Gemini, which is from Google with 1.5 trillion parameters, and Claude, which is from the Mistral folks. So that's 2 trillion. And the idea is that the more parameters that a model has, notionally, the more powerful it is. Now, the downside, obviously, with more parameters is you need more processing power for it to do that processing. And depending on how powerful it is and the processing power it's got access to, the slower the responses might be. So there's a balance to be struck between the number of parameters and the performance of the model. And I think that's obviously where something like the original ChatGPT got it right, because you could whack in some text and you'd have a pretty quick response from the back end. So when you're building user experiences using these GPT backends, that user experience needs to be taken into consideration. And there has recently been a GPT-4 Turbo released, which is certainly substantially faster in its response generation than the original GPT-4 was when it first shipped. As you can see, just looking at this slide, there are lots of models out there. Some are commercial, some are open source. As I said on the previous slide, the Azure AI service provides access to many of the open source models, whether it's Llama from the likes of Meta, or the Mistral large ones from the folks in Europe. You have access to that through the system here. So things like Gemini, we're never going to see Gemini, I would imagine, because Google wants to keep that one close to their chest because that's their secret sauce. But you've got a lot of choice here, and this is just large language models. There is now a shift towards these things called small language models, or SLMs, which is a way to drive this sort of processing capability down onto edge devices. So Phi 3 was announced from Microsoft at Build last week, and that's something that you can now publish out onto edge devices if you want to. So you can see on the left-hand side of this slide under the Nano Q, you can see Phi 2. So this slide was before Phi 3 was announced, but those sorts of extra small and nano scale models are probably going to be the sorts of things that show up on your mobile phone or on your Copilot Plus PC in the next couple of years. I don't think you'll be seeing the likes of GPT-4 or Gemini down in these devices anytime soon, given the processing power that they require. How are we doing for questions? Any questions? I can't see the chat window, so
No.
The data that goes into training some of these models. No doubt everyone's seen the kind of the way people have been looking at some of the weird responses that the Google search results have been giving them. Some of that is obviously based on the fact that they've chosen to go with Reddit, which, let's face it, isn't always the most appropriate of sources for knowledge. And that is a challenge across this whole space, right? And when you talk about hallucinations, these models have been trained on a large data set which will contain an undefined number of inaccurate, out of date, purposefully, false statements, and the models have no idea. They don't know what's true or false. They have no morals or ethics. So at the end of the day, we need to take that into consideration when we're building these solutions, and that's why I think things like responsible AI and content safety play a big part in this, because it's fine to hallucinate and tell me how to make a wood chip pizza, because that's what I asked for. But when I want my young child to be able to ask Google how to cook a pizza, I don't want Google to recommend they make a wood chip pizza with firelighter fluid on top, right? So getting that right is a challenge, and I think in the rush to build all this new stuff, we definitely need to be careful with that. What are the limitations to LLM development? It's absolutely processor power, because the training to build these models requires multi-million dollars of compute at the sort of scale that you only get in a cloud like Azure or AWS or Google. So ultimately, they're held back by just the raw compute that they can access, and it's why Microsoft and OpenAI have the partnership they have, so that OpenAI has access to that raw compute inside of Azure. In fact, I think Microsoft said they build a dedicated supercomputer just for OpenAI's use, and I'm pretty sure if you looked at the Google literature, they would be talking about what they're doing inside of their data centers as well to enable Gemini to be built and trained over time. So that's a good question for sure.
We've got one here actually from Stephen. So how will LLM development be influenced by quantum computing when it comes, and what are the limitations of LLM development, processing power, or access to data?
That's a good question. Well, we just talked about processing power. Quantum computing, I honestly don't know. I can't talk to you about that. Obviously, a classical computer versus quantum computing are two very different strains of computing in terms of how they function. I must admit, I don't know enough about the way quantum computers would handle the sorts of workloads that are required to train these models. Theoretically, if we think about it, quantum maybe offers a substantial leap forward in training these models, but I don't know that. I have spent no time looking at it. That's just me thinking about the difference between classical and quantum computers. What I would say is that initial quantum computers will be hyper-specialized in what they do. They will not be general computers in the way that we know general computers today in our world. In the same way that classical computers started off with hyper-specialized use cases. So things like cracking the Enigma machine code during the Second World War was hyper-specialized computer. And if we did that today, we would need to build a dedicated computer just to do that. We would use maybe a GPU enhanced machine, but it would still be a general machine overall. And if we think about, just to finish off that thought, if you think about what Google did with something like the TPU, so the tensor processing unit, and Microsoft's done with the NPU, or the neural processor unit, we're now starting to see dedicated types of processor to do certain types of workloads. So maybe we are going back towards specialized rather than general computing, but I don't know what that would mean in the context of quantum computing. I don't think we're far enough advanced in that space yet to really talk about that in any level of detail. The other key concept I did want to touch on was this idea of tokens. So you may have seen tokens floating around, so I just want to talk a bit about it. Token is not a word and it's not a character. Token can be a combination of those things. Tokens can include spaces and what's the word I'm looking for here? Things like full stops and commas, so and double quotes are all considered types of tokens. When you work with GPT models, the way that you work with them is you send them text or maybe even images, but even images ultimately get converted into a type of token. The model itself will take a certain number of tokens and then return a certain number of tokens. Overall, these models have what's known as a token limit or a token window. And you may have seen something like GPT-3.5 16K floating around. So that 16K is 16,000. That is the number of tokens that model can handle. And that is a combination of both the tokens it receives in the request and the tokens it sends back in a response. You may have seen Google did a demo a little while back where they were talking about, I think, the Gemini, when they announced it, had a token window size of like 1.5 million tokens or something, which is enormous, and that you could ingest, an entire book or an entire massive source code application and still have token headspace to get a response back. That's all well and good, but if you think about the processing power it would take to process 1.5 million tokens, not sure how useful that is. But at the moment, with the OpenAI models, I think the largest token window we have at present is 128,000 tokens, which is actually quite a lot. And even at 16,000 or 4,500 tokens, which are some of the smaller models from OpenAI have, you can still do some really useful stuff with that. And I'll talk a little bit about that in the demo. But I did want to talk about tokens because oftentimes you hear the words tokens thrown around in the context of generative AI, and wanted to show that, okay, well, in this sentence here, we've got 207 characters, but actually the way that would get broken up by the token processing is shown here. So it's 43 tokens. I'm guessing the next question is going to be, how do you know how many tokens your piece of text has? You don't know that in advance because the tokenizer that you use is hidden from you. But what you do get when you interact with the OpenAI models is the metrics that will show you how many tokens you received and how many tokens you got back. Ultimately, you just need to be aware of what your total token window size is when you interact with the model, so that you can take that into consideration when you talk about context with the model. Hopefully that makes sense. Yep, one request does not equal one token. No. And unfortunately, in our industry, token is a loaded word, right? We've seen tokens used in a lot of different places, and I guess we've run out of words to describe things. So, in this case, this is how a token is represented.
We've got a question from Alan. Just to jump in before you get started again. So Alan's asking about providing the whole conversation history each time, which progressively consumes a larger part of the token window. So that's an interesting one.
Mm-hmm. That's a good question, and I will talk about that. So when I do the demo, we'll talk about that. But you can actually see here on the last point on this slide as well, I touch on it a bit. So when you work with these models, you have a few knobs that you can tweak to vary the way that they behave. So as I talked about earlier, GPT models are just big predictive engines. They go based on the fact that you wrote TOM, and that was what the prompt that you sent them. That could be tomato, could be tamale, could be tomorrow. And what will happen is that the GPT model will basically generate a list of potential matches to complete TOM. And then what it will do is it will rate those based on match. So if you think about the way models work, is anything between 0 and 1, so 0 and 100%, where 100% is an exact match or really positive. So when you get that list back, you can control the number of items in that list that you want the model to consider as part of its response. So that's top P. So the percentage of top responses to consider suitable to returning to the user. So that increases the number of possible responses that the model can choose to send back. The other thing that you can control is a thing called temperature, which is the randomness of the responses. And oftentimes you'll see people talking about changing both of these at the same time. And you actually shouldn't do that. So what you should do is you should keep the number of responses set to a consistent value while you play with temperature. And what temperature will do is it'll give you a little bit more randomness, a little bit more creativity in the responses. So if you've used the Bing or Copilot. I forget what they've called it now because it's changed so many times. But if you go to the Bing search engine and you open the Copilot feature on there, you'll find that there's a little box on that screen that says more accurate, more creative, or balanced. And what that's doing is that's affecting the temperature that the model on the back end is doing. So when you've got that temperature like 50%, so bang in the middle, you're getting a balanced response. So it's a little bit creative and a little bit balanced. If it's balanced, it's going to be really boring and stick really just to a small area of knowledge. And if you set it to, like highly random, that's when you start to get really weird responses, or you get repetitive responses, because it's just generating almost garbage at that point, because you're right at the other end of that probability model saying, out of everything that you've seen, go right to the really random end of that. So top P, how many of these things do I want to consider to respond with? Temperature is what's the variation in things that I'm going to generate as a possible outcome. Typically, you only change one of those two things depending on what you're trying to do. If you're trying to build, say, a gaming engine, you'd probably set your temperature to be quite random, so you get some really good variation and randomness in the responses. But if you're building an internal chatbot for your business, you probably set the temperature quite low, and then maybe have a higher top P so that you get a little bit more variation in the responses that you get back. System message, and this is in the context of completions and chat with the OpenAI models. In the assistance world, the system message is called something different, but the idea is the same. And what the system message does is it basically says to the model, hey, when you respond to the requests that you're about to receive, behave like a chef or a recipe assistant or a personality of some sort, or use this style in your responses. And it's literally your way to control the way the model is going to behave. And you need to send this with each request that you make to the model. And to Alan's question, that can become a problem when you have a large chat history going on, because that system message is always the first message in the top of the stack that you send to the model. And if you've got a very long chat history, as you can imagine, that system message is going to be well and truly right at the top of that chat history. And the models have an attention deficit, shall we say, where the further away something gets from the top of the stack, the less they pay attention to it. So that can be a problem. And there is a solution to that, which I'll talk a little bit about. But system message is important because it kind of controls how the GPT model is going to respond. If you don't give it a system message, it's just going to behave like a general AI assistant, which is probably what you see with the ChatGPT systems that you're used to. When you interact with a model, you write a prompt or you upload an image, which actually generates a prompt in the back end. And then that gets appended to the system message, which is sent as part of the request to the model for processing. Model generates a response and then sends it back. And that is then added to a thing called the context window or context history. And then you can choose to send as many of those request response pairs back to the model with each following request to help the model keep context. So if you think about when we have a discussion, we know what the person that's talking to us was just talking about. These models, given the way they work, have no context unless you give it to them. So to Alan's question, which was, that conversation history, the way that you maintain context is you send back one or more user prompts and the response that was generated by the model, and then you append your new question on the end of that. That does go into that token count. So there is a limit, and the way you manage that is you have to trim the context history, the chat history, so that you don't break the window size that the model's got. Now, I will say that the assistance implementation, or the assistance API, which is new from OpenAI and is in preview in Azure as well, takes care of that for you. So the idea of thread history is maintained internally inside of the assistance API for you. So you don't need to worry about breaking the token context size, because the assistance API does that for you transparently. So it's definitely one benefit of moving to the new assistance model, because a lot of the manual work that you do in some of these first generation systems is taken care of for you by the new API. All right. So hopefully that answers Alan's question. So we're almost done with slides. and then we're going to get into the demo. So the piece I wanted to talk about next is this idea of Retrieval Augmented Generation, or RAG. I've got to admit, I never remember what RAG stands for. I just know what it does. So it's always good to see Retrieval Augmented Generation on the screen just to remind me what that R stands for. So what this does is it actually takes the general capabilities of those GPT models that are really good at summarization and have some general knowledge, some of it accurate, some of it not so accurate, to generate responses. And it augments those responses, and it does that with data that you provide to it that might be specific to your use case. So for our demo tonight, it'll be recipes and cooking instructions, but I've built systems that will help people do tour planning to go on holidays. Obviously, a big use case is maybe internal chatbot for your business that can be informed of what's going on inside the company, so people can ask questions about it. If you look at GitHub Copilot Enterprise, the GitHub Copilot Enterprise deployment model is actually using RAG to give you access to internal knowledge bases inside of your organization, whether they're in GitHub or elsewhere, and also ingesting repositories so it can answer questions that are specific to your code and not just general questions about general code that's floating around. They're using this, this pattern, which is called RAG. When you send a user prompt to a system, a GPT system that's using RAG, what happens is that prompt is not only sent to the model for summarization, but it's then also used to perform some lookup in a third-party system. It will find matches against that third-party system that are returned to the model and used for summarization. So we'll have a look at that when we look at the demo. So the kind of the flow at the bottom there kind of shows you what that looks like. You ask a question, it's run a search is run against some sort of data store. Any matching results are brought back. You take the original user prompt and the user response. You send it to the large language model for a summarization, and it sends the response back to the user. That oftentimes will use things like citations that will point them to where the data came from that generated the response. Again, if you use the Copilot feature in Bing, you'll see that it will give you a response, and then it will give you a series of links to where it got that information from, which is super important if you want to have confidence in those results. And with using RAG, you can also tell the model not to freeform and go off and make stuff up or use its general knowledge. You can say, just respond using the content that you're provided with in this response from the data store, and don't attempt to make anything up. So you can generate some, quite reliable systems when you build systems like that. I'm going to quickly talk about systems pattern. So it's beta and it's just shipped. We've been having a bit of a play with it. It's designed to abstract away some of the complexity of building GPT systems on the server side. So I think of it as semantic kernel or lang chain, but on the server. And what it does is it allows you to take the back-end model. It abstracts away the management of conversation history. It abstracts away the complexity of file search, so you can ingest files and they will be automatically vectorized and stored in a vector database for you on the back end. And then basically what you can do is you can use either a file search tool or a code interpreter tool, which will actually generate code on the fly for you to go and look at file contents or other activities for you. Or you can use function calling, which are also called tools these days by OpenAI, which is custom code that you can write to go and say call third-party live APIs to get data back. This is new. I think this is probably where we'll end up with all GPT-based assistants or systems in future, or something like this, because it just removes a lot of the sort of boilerplate work you have to do to build solutions. But I did want to talk just quickly about it. So that's my slides.
All right.
Everyone came for a demo. Yep. So before I get into the demo, looks like there's questions.
Yeah. So Darren's asking about the data store that you can use for the RAG augmentation. So any constraints around that, or I suppose the question is, what data stores can you use?
So there's a bunch of different. So there's no real pre-described system to use. So the prevalent one you'll see a lot of people talk about is vectorization. and embeddings. So vectorization basically takes the content that you want indexed and vectorizes it into, it's basically an array of numbers. And then when your search, when your user prompt is received, the user prompt is also vectorized. And then a clever piece of mathematics is used to do a nearness search in the vector database to find content that is the best match for the prompt. Those vector databases are not new. They kind of come back to the fore with their popularity in this use case. They're very powerful because they're quite efficient and they take less space than plain text or semantic type searches do. When you think about things like token limits, they can be quite handy if you're doing this in the context of a token limit, not having to think about that. But ultimately, when you're using something like function calling or tools, and even just out of the box RAG, you can just go and call any data source as long as you can control the volume of data that you get back and how that's provided to the model. So you could say, for example, that search that you do, rather than hitting, say, a vector database, it could go and run a query against a SQL server. And that SQL server might have a series of columns in a table, and you might do a like search, a very traditional type of match in SQL Server, and then you would need to return what's appropriate to be summarized inside of the LLM response. So you need to think about, what am I trying to achieve with the data that I'm querying, and how's it going to be represented to the user who's going to receive this response? And are they going to need to do something like get further information, and how do I provide that as part of my response so that the user can find that information? So that might be through a citation, which might be rendered as a hyperlink in your bot. But ultimately, RAG can be implemented using any number of approaches. So the first cut of the Microsoft bot framework that they built to allow you to basically build an end-to-end solution using Azure OpenAI uses an extension that Microsoft built themselves, which behind the scenes uses Azure OpenAI Search, and you can either use semantic matching or vector matching as part of that. They don't expose how that happens. Behind the scenes, it's just using an Azure AI search service, which I've actually got one sitting here in my Azure portal that I've got open here. So it's not really prescribed. Like, you don't need to choose a RAG provider or a RAG database. You just need to make sure that whatever data you pull back from it isn't going to break your token limit and will make a sensible response back to the user, if that makes sense.
Cool. And Francis, just asking you quickly about assistants versus agents.
Look, I think so. I must admit, I've spent a bit of time looking at the assistant implementation and playing with agents as defined. I can't say hand on heart that they are one and the same thing. They would seem to be at first glance, but I can't guarantee you that's the case. But a good question. All right, so let's go ahead and see how we can go with building an assistant. I did cheat a bit and provision some stuff in Azure already. I've got an Azure OpenAI service here that is stood up in my subscription. If you do want to use Azure OpenAI service, you do need to be whitelisted for it. And typically it's for business use only. So you've got to fill in a big long form before Microsoft whitelists you for it. Once you do have access to it, though, you can go ahead and deploy the models. They have their own funky Azure OpenAI Studio, which allows you to interact with it. And this is where we'll spend the rest of our time for today's session, because it's a good way to get your head around what's happening with these models. All right, so you can actually see in here there's an assistance playground. I'm going to use the chat playground, which has been around for a while. You can see there's also bring your own data here in the middle of the screen. We will take a bit of a look at that in a minute. But what I have done is, in this environment, I've got a couple of models deployed. So I have Cooking Assistant Demo, which is just a GPT-4 model that's deployed. I don't know what size that is. Might be a standard 4K model. And then I have a text embedding Ada 2 model, which is used for my vectorization. So when I upload my content, this model is used behind the scenes by the Bring Your Own Data capability to actually vectorize the data, which is then written into an Azure AI search index, which is used to inform the Cooking Assistant's responses. You'll see here that there's a chat playground. So this is a really good way to get your head around what's happening inside of the system. So you can see on the right-hand side here, we've got some configurations. So my deployment is my GPT-4 model that I've got deployed. I can change between deployments depending on how many I've got. Parameters, so you'll see here we've got max response. So this is a number of tokens we want the response to be maximum. So it means that it'll limit the amount, it'll mean that the model will try and limit the responses it generates to being no more than 800 tokens in length. That doesn't mean that the overall token limit is 800. It just means each response shouldn't be bigger than that, where it can help itself. Temperature, as we were talking about, so it's set at 70%. Top B is at 0.95, so it's set quite random at the moment. Stop sequences, so stop sequence is just a way that the model tells you that something caused it to stop, and it might be that it ran out of tokens or something like that. And then you've got a couple of penalties, which is basically just a reinforcement learning thing to tell the model, try to be a bit varied in your responses. So, don't use the same word all the time, don't use the same characters all the time. Typically, I don't mess with the frequency or presence penalty, I just leave them as they are. And just play with the temperature and top P depending on what I'm trying to achieve. You'll see here we've got a system message template over here on the left. By default, it's just got you are an AI assistant that helps people to find information. And you can then go and chat with it. You can say, and it looks like I've got 128K tokens here. So my GPT-4 model's got 128K. So, it's a fairly vanilla, boring response. Now, the interesting thing with this playground is you can either show the JSON representation of that. So here's our system message. Here's the question that I asked, and then here's the response that I got back. That is always a good way to start thinking about how to interact with these systems, because that is the extent of the kind of the message transactions that you have with a GPT model. So the system message sets how we want the model to behave, and it does count towards the tokens, obviously. But the more accurate, more comprehensive your system message is, the more control you have over the way the model responds. So I've seen system messages that are substantial, like massive, because they determine the tone of the voice, so the way that the bot responds, so pretending to be somebody else or to talk in a certain style, to not respond in certain ways. So you can give examples of things that you don't want the system to respond with and put them into the system message. And because it's a system message, it kind of has priority over the other items that you have here. And then here we've got a user and an assistant request response pair. This is the start of a chat history. So if we just quickly go back and we do another question, and we say, how large is the moon? Now, I don't know whether this will be accurate or not, because it's obviously going to generate it off of its general knowledge. All right, so that's responded, or it's continuing to respond, so it's streaming the response back. All right, so if we do the JSON here, you'll see that this would now be considered to the question we had earlier. This is what your history would look like. So each time you have an interaction with the model, this forms as part of your history. Now you'll see over here, it says session settings on the right. and you can see past messages included. So we can control the number of messages we want to send back. So that'll be a user question and an assistant response. We can limit how many we want to send back as part of our interaction, and that limits the amount of tokens that are being used as part of the request response cycle. We always need to send back the system message because it's what gives context. But by limiting a number of user request response pairs we send back, we limit the amount of token space we use. But we also do, and it's worth noting, is we also do limit the ability for the model to have context from earlier in the chat because we're trimming some of that content. But it is something that you need to do if you think you're going to have long conversations between a user and an assistant. You basically need to think about how you manage that chat history. As I said, the new Assistants API does some of that for you, but you may want to have more control over it than that ultimately when you do this. So that's good to know. When you set these systems up as well, you can do a thing called few-shot learning. And what few-shot learning does is it gives the system an example of what a user interaction and a bot response might look like. So it could be that I use, this user and assistant response pair as a few-shot learning example. So it gives an example to the back-end system of this is how you should behave when you receive this type of question. Now, we'll see when we use our own data, that goes away. We lose some of that control, but for many other systems, that's also a good way to set the behavior that you expect the system to have when you do that. So what I want to do is I'm just going to quickly grab my system message here. Where did I put it? All right, here we are. So I'm going to say you are a cooking assistant named Jamie Ovola. You will use provided recipes to help people prepare meals. How do we want Jamie Oliver to talk? How should Jamie Ovola, I should say, sorry, let's not get ourselves into trouble with Jamie Oliver. How would we like Jamie Ovola to talk?
Posh.
All right. Okay.
Stephen's asked for Scarlett Johansson's voice or Scarlett Johansson's voice.
Yes, yeah. Yes. So we have to apply our change for that system message to kick in, and you'll see that I'll get a pop-up saying your chat's going to be reset. So that's fine because we've set a new system message. So let's turn that off and we'll say, let's clear the chat.
It's not very snappy.
Yeah, so I would suggest that there's probably a combination of time of day and the model that I've selected. So, so you can see here it's already picked up a bit of a tone of voice, my esteemed acquaintance, and it said that they're Jamie Ovola and they're at our services a culinary assistant. So it's pulling, even just a simple amount of work in the system message gives our bot a good response. We can start to set some boundaries in here, which I won't go into, but we could start to do some extra stuff in here. Now, what we're going to do is let's add some data to this. And this is a quick way to get going with bring your own data. When you would do this at an enterprise level, you would do it slightly differently to this because you would have an existing data source that you would connect to. But for the purpose of today, what I'm actually going to do is I'm going to use a blob storage account. And I've got an existing blob storage account because like any good chef, here's one I prepared earlier. And I've already uploaded a series of files and I've got an existing AI search resource. And then what I'm going to do is I'm going to call this cooking demo 28th of May. Oops, 28th of May. Now I can at this point set it to do once or hourly or daily. So let's just do it once. I'm going to add a vector search to this database. Now this is where our embedding model comes in. So I can just select that. I'm going to say I want it to do, I'm going to do vector and keyword search. I'm going to leave the size for the, so behind the scenes, what it's doing is it's actually ingesting a series of PDF files that have recipes in them. And then what I will do is I will ask it specific questions about those recipes. So while it's ingesting that file data, let me just grab one of those recipe files and I will show you what it's got, and we can ask some questions about this. Where are we going? There we are. So it might be, I'm hoping, because I didn't upload all of the files, so I'm hoping it will. So this is, and it loads. So this is the recipe for beef bourguignon. So this is hopefully one of the files that's being ingested at this moment. As you can see, it's just got serving size, how long it takes to cook, what the ingredients are, and then the directions for cooking. So we should hopefully be able to ask questions about cooking beef bourguignon, and it should know what to do with this. So don't worry about the fact that it says data was truncated. It just means that we haven't pre-processed our data properly to make sure that nothing is longer than the maximum limit for those chunks. And then what I'm going to do is I'm going to add one thing into my system message here. Only respond, and it used to be, and this is how fast these things change. It used to be that when you set it to respond to your data, you could set in here that it should only use the data that you've uploaded, but that seems to have now been removed, or it's actually now just the default. Only respond using the file data that you have access to. If you don't have a recipe, apologize and suggest an alternative from file data. Do have. So the interesting thing that I see a lot as well with system messages is people make their system messages massive, which is okay, but then they put competing statements in their system message because they're so long they forget what they wrote, and that's a real problem because then obviously the system's got competing guides and it doesn't know what to do. So certainly getting that system message right is important. If you'd have said to me 10 years ago there'll be a job called prompt engineering, I would have laughed at you and said that sounds stupid. But actually I think, having spent quite a bit of time in this space, it's a real skill to develop, because if you can write system prompts really well, you can get these models to do some really amazing stuff for you off the back of that. So it looks like our data is good to go. Let's clear the chat. So they'll do that. What's the main ingredient in beef bourguignon? I've probably misspelt that. Let's see how we go. And I didn't even ask a question. How bad is my English? All right, the main ingredient for beef bourguignon is lean stewing beef, which is cut into 2-inch cubes. And if we open that, we'll see that that was our beef bourguignon. So we've even got the reference to it. So if we click on that, I suspect in this context, it will probably try and open the PDF file out of the storage account, but you have some control over that. And we can see the data that was sent back, including the reference there to doc1. And if we look at the code, this is a great way as well to get going. We can get Python, JSON, C#, and curl, so we can even do this just using the RESTful API calls. But if we look at the Python version of this, which was already open, we can see how to set it up and call it. And then we can see, calling the API to find the deployment. And then it's using this thing called bring your own data adapter, which is how it does the RAG pattern with the data that you've uploaded. And then it makes the call. So there's our system message. There's our API key, which I will delete after this. And that way we've already got code to get going, building against this API. And all we've had to do is use this front end system here to do that. Now, the interesting thing here is, let's see what. So there are other files in this file upload. So it could be that there's a duck recipe hidden amongst the files. Let's see what it comes back with. So you are right, it's a bit slow, but I suspect that's just because it's a GPT-4 model. Yeah. So it's still only partway through that. There we are. So you can see here that it said, I don't have anything for duck in the documents provided. However, I can. So it's fulfilled its requested role of telling you how to do it, and it's done it in quite a nice fashion as well, right? It's got a little bit of character about it, and again, it's got the references to the documents, and you can see this one's been split up as well. Now, I said I would build this in half an hour. I've kind of cheated that is built, but now if I wanted to actually deploy that, I could actually export the setup and deploy it into another environment if I wanted to, or from here I can actually deploy it into a new Azure web app. So let's go ahead and click that, and I might take any questions while that's running in the background. Let's have a look.
What sort of web app does it mean?
An Azure web app. So it deploys a standard Azure web app into the environment that you select. So you can deploy it into an existing web app if you want. Okay, well, I'm not going to do that. Select the location. Interesting. So by enabling chat history, you also use Cosmos DB. So we'll do that. And then what we'll find if we just go back to the Azure portal. This may take a little while to run. Where are we? Oh, that was from another talk I did where I actually deployed a bot using that pretended to be C3PO. So that's there it is. That's the right source script there. So see how it's going with that. So it's still deploying. Anyway, so look, the point I wanted to make is that you can get going really quickly with this stuff. So even if you're wanting to build an internal chatbot for your organization, or maybe you're thinking about building one, say, for your kids to use or for the family, you can start fairly quickly with these things. Even if you're not deeply familiar with coding, you can still get the fundamentals in place and get a really quite robust solution that gives you a web front end and a user experience that you can then customize. Because the system is a RESTful API on the back end, it's really easy to bolt it into pretty much any system. So as you saw, obviously the samples included the ability to invoke using curl. So, you know, at this point, you can do anything you want. And I actually think, despite the power of their models, I think the actual secret sauce for a lot of the value that OpenAI has delivered is actually the fact that they made the interaction model for using the various GPT models they have so simple, and that you can do it via a RESTful API. So look, let's see if that deploys in the meantime, but just open up for any questions. I'm just going to flick over and see what's sitting in StreamYard, see if there's any questions in there.
Yeah, nothing yet, but now's a good time to ask a question if you've got one.
I'll leave that. So not a lot of code. I think we lost Francis. But I think you might get carried away in a Visual Studio Code window because it's kind of boring. I quite like the visual representation that you get with this user experience, and it allows you to explore, some of the details like parameters. So we could, we come in here, we could have some fun and set the temperature, right up. In fact, I think with bring your own data, you don't have as much control over some of this stuff because it tries to keep it pretty accurate based on the data that you've provided it with.
That's good. Really, no questions?
Maybe I answered them all while I was going.
We had a lot as we went. Maybe that's what happened.
Yeah. So it's stood up a Cosmos DB account.
Yep.
My search service.
How many recipes did you upload, by the way, for the bring your own data?
Yeah. So let's have a look at that. That's a good question. Not many in this context. So I think it's only a half a dozen or so. So they're just open source recipe books. But you can do. We've done much larger. At work, I've done much larger data sets than what we've used here. So we have a look at the demo. So that's all I've uploaded, and they're not massive in terms of how big they are. But typically, what a big part of building these sorts of systems is your data prep for indexing and thinking about how you want to use data to answer the questions that you are going to receive for your bot, because ultimately the responses that you get from the service are only going to be as good as the data that it's got access to and the way it's organized as a way to answer questions people have against it.
Does it automatically chunk them up to fit the context window size, the number of tokens?
So it chunks them up. So part of the indexer, so it's kind of hidden to you when you use the bring your own data feature inside of the Azure OpenAI Studio. But if we have a look at the, this is the Azure AI search service, and you'll see that we've got a couple of indexes in here when it loads. So you can see we've got, that was our 28th of May index. And if we open that, we can see that it's been chunked up.
Yeah, so there's 83, but there's only like 16 recipes. So I guess that's doing the chunking.
Yeah, and because what happens if you choose only once, index only once, what happens is the indexes are created, they're run, and then they're deleted. If you choose to do hourly or daily, you'll find you can come into your AI search indexes, and you'll see the indexes that are running. And there's two. There's one that indexes the whole document. Then you have a thing inside of an indexer called a skill, and that skill is the thing that causes the embedder that actually does the chunking. So let's have a look here. Yeah, no, it's not set up here. But if I went back into the playground and I chose to let's remove the data, we can add it again. In fact, that's the wrong one. Let's not do the index. Search results. So if we run this, and now we go back to our index, our search service, what we should now find is that, depending on the timing, we should find some indexes sitting here. Okay, so you'll see that you've got two indexes. So one is called the indexer, and then you've got the indexer chunk. And if we have a look, I don't know if we can edit these while they're running. So you can see it processed 8 documents. And then if we have a look at the definition, we should be able to see that it's calling somewhere in here. So there's our skills. There's our skill sets there. So if we come back to here, and we have a look at our skill set. You'll see here, it's calling the OpenAI pre-processing jobs, and that's where it's actually calling the embedding model that we've chosen. So it's not specifically mentioned in here, but basically that's what it does behind the scenes. It uses that embeddings model when you call this AI. So that skill set is the thing that actually does the vectorization for you. So you can obviously set all that stuff up yourself manually if you want to. And in an enterprise, you probably would. You probably have a lot of this stuff already pre-configured. And you wouldn't use BYOD. You'd probably use a much more generic RAG pattern where you might use AI search directly, or you might use a tool or a function call that might go and get that data for you in real time, rather than doing this sort of model, which is really just a quick way to get going. So let's have a look and see that. Did that deploy?
Yeah, it looks
All
like
right.
it's ready.
Let's launch the web app. Okay, so none of you will have access to this because it's protected by Azure AD, because it's designed for the enterprise.
I've got a few questions actually. So in the meantime, while it's, I know we've got to answer. Yep.
Is there a way we can control output? I mean, a way to validate the response is somewhat correct before we display the output to the user? No. So that kind of aligns with the question that we had previously about using content safety. So content safety is, there is some hallucination control, but ultimately if you have content that you want to make sure that, let's just go ahead and do this, create a demo one. So you can see here we've got the ability to block copyright content, whether it's code or text. We can shield from jailbreak attacks, which is people trying to break the model's instructions, and then indirect attacks. So indirect attacks are quite interesting because people will have a line of questioning to get around the prompt for the model, and they won't do it by asking direct questions. They'll kind of set the model on a train of thought to pull it off track. But you'll see that there's no ability to control things around hallucination per se. And if you have a model that is doing something critical, which is either endangering a life or has some other critical aspects to it, it should always be reviewed by a human, always. And I'm not going to say any different on that. So these models are amazing and they generate amazing content, but it says right there, AI generated content may be incorrect. So always keeping that in mind, right? And that's an important part. I'm not one of those people that will say that these things are infallible, because they're not. And it's always a discussion I have with any customer about building these systems is think about how you want to manage that, because it is reality. it is very easy when you know how to work with these systems to get around the system prompt and other protections that are in place. And it's usually just for trivial things, but sometimes reputational damage is far more important to organizations than the accuracy or comedy value of something in there. So that was one question. I don't know about the multimodal voice stuff with GPT-4 voice. So I haven't played with it, so I don't know off the top of my head. It's certainly it generates cost when you enable that inside of the Azure environment. I couldn't talk to you about what that means from a token limit perspective. I would hazard a guess that it's probably doing transcription to convert that to text. So obviously, the bigger the chunk of audio that you send it, the more text it's going to generate, but that's just a guess. Yep, if you have dynamic data, that's where tools or function calling comes in. So let's just cancel this. So realistically, what you would do is, let's just have a look here. So the kind of out of the box solution Microsoft kind of points out is RAG with Azure AI Search. There's also I was going to say function calling because it changed. It used to be called function calling, and OpenAI renamed it tools. But the problem is obviously tools is now such a generic word that if you look for tools, you get up all sorts of weird results. So basically what you do is you have this idea of a function call which augments the inbuilt ability of the agent. And what it does is the classic one that they have as part of these samples, and I'll see if they have it, is you have this is your function call, which is called get current weather, which takes the location and unit Fahrenheit. It's hard coded. Unfortunately, most of the samples you'll see will use a hard-coded function call. So this is actually the implementation. And then what you'll see is that this is the conversation. You'll see this is the message up here. So the role is the user. And then there's a tool definition. And this is where the model goes, okay, well, I got this question, or I got this user prompt. Here's a tool that might be useful to answer that question. So you would need to obviously write the tool for your dynamic data source so that it makes sense in the context of the user prompt that you're going to get. And that's kind of how it works at the end of the day. And then you need, obviously, as part of setting up the chat, you need to tell it what tools there are to use and then how to select the right tool to use depending on the situation. So this is a bit of a contrived example. It's only got one question and one function, but that's how you would do it without having to build a static data set.
All right, I think we really call it there. Just thinking we've gone quite a bit over time.
Yep.
And we don't have any other questions that we really need to answer, I think. Yes. So
I broke my 30-minute hard limit by a long shot. So
well, we did ask you a few questions on the way, which is, I mean, what we're here for, right? Much better to have an interactive session than, just a drive, without questions where everyone just watches. So yeah, I think it's been
many
good.
LLMs in the kitchen, I think.
So yeah, we got some comments here. Fantastic presentation and thanks for a clear explanation on complex concepts. So I agree, it's been a really good presentation and you've fielded all the questions which people have chucked you from all different directions too. So I've enjoyed it and learned a lot too. So thanks very much, Simon. So for the JetSbrains,
thanks for having me and apologies again for being late.
Oh, no worries at all.
Yeah, no worries.
Thanks for staying late too. And being in two user groups at the same time.
That's on me. That's not on you.
It's like me and Jay thing in the same room.
So for the JetBrains licenses, is everyone ready? Everyone set? All right. So what is the biggest thing that Azure OpenAI adds on top of OpenAI? Let's see. More AI, Francis. You can't win anyway. And we'll wait.
More AI. No, that's not the right answer. Not TPU. TPU is PTU. Well, yeah, not really. No, PTU is
think back to the start of the presentation.
Yeah. Not throughput.
I don't know. Maybe lower throughput.
Depends on the context. No.
I think Darren might be on the right track.
I reckon. I think they're all good. Yeah, awesome. Thanks for the spam there. The last one.
Yeah, no JetBrains license for Zoom.
Yeah. I reckon. Look, I think out of all of the answers I see, I think that one that you mentioned, James, is maybe the most accurate.
Darren's one, the response
Yeah,
results.
yeah.
Yeah. All right, that sounds good. Yeah, I was thinking about all the filters and things that that we just saw at the end that Simon was showing, where you could turn on, no cuss words and no hate speech and all that sort of type stuff. So, all right, Darren, send me a meetup message, please, with your email address, and I'll send you through the JetBrains license. And yeah, I did check. You can get the ChatGPT plugin for your JetBrains as one of the prizes. So that's pretty relevant for the talk. Cool. All right. So next question is, what is a token in the context of this talk? It's maybe a tricky question. See what people have. In the context of the talk, thanks, Francis.
Sorry, I didn't get the memo. It's still coming.
That's all right. You probably already got your JetBrains license that you need. All right.
I mean, he's definitely got a T-shirt, so.
I had to buy this actually. All
right. Stephen seems to be giving us good answers there. Yeah, it seems to be mainly like a word from my experience, but not quite. And probably, as Simon said, right, it can include the punctuation and stuff, and you got the limits measured in it as well.
And the models think in tokens, right? When they respond with tokens. They don't respond with characters. They respond with tokens, and token could be ato on the end of tomato, or amale on the end of tamale. So but unit of measurement for usage. Yeah, I think Stephen's in the right. I'd say Stephen's in the right ballpark with that, because until you work with these things a lot, it can be hard to grok exactly what the token is. So that's cool.
All right, thank you, Stephen. That's please send me your email address as a meetup message, and I'll send you through the JetBrains license. All right. Well, thank you very much, everyone. Oh, the only other thing is, does anyone who chuck in the chat if they're keen for a pub meetup for next meetup, which would be late June, last Tuesday in June.
Maybe not. It doesn't have to be the Tuesday. But
I suppose we could swap it around. Yeah, Tuesday's not the world's best pub day.
Yeah, just we can do a poll like last time.
But Stephen's keen, so that's at least one person. We won't be alone. It's all right. Anyone else want to come?
Yeah, you might see me and James in the same room.
Yeah, we'll try and definitely turn up.
And we might have to entice them with their JetBrains licenses. I know.
Yeah, well, we will have JetBrains license to give away.
Yeah, here we go. As I mentioned, there's
social distancing. 1,000 k's away.
That's no excuse. 1,000 kilometers. It's like it's still on this country, and it could be on this continent still.
This is true. All right, so we've got some interest at least. So we'll do a poll or something like that before next month and work stuff out.
I think you should hold JetBrains licenses. Only people who show up in person get their license.
Right, maybe we'll have it the first 2 people to turn up get the license. I think last time we did the pub, we didn't give away the licenses, so.
Oh yeah, in theory we should have 4 licenses. No.
I think we should do it on who turns up first. We just set a time, and if you're there on the time, the first 2 people get it. All right, cool. We will send you more stuff around that. And again, thank you very much, Simon, for such a useful and professional talk as well.
Yeah, this is definitely one of the best I think talks about LLM and RAG, and you've explained it really well. I think I've actually learned quite a bit actually today. So it's been awesome.
Great, thank you. I'm pleased. Hopefully everyone that was online got value out of it as well. Appreciate it.
Very much. All right, so I'll call it an end here because we're at 8:30, and see you next month, maybe in person.
All right.
See you later.
Guys.